All right, guys, this is going to be the lecture for homework 21, just systems of equations. Marker running out here. Systems of equations. Fancy name, but for really what it is just two different equations you're going to solve at once. So, for example, a system might look like this. Y equals 3x minus 5, and then below that they might have y equals x minus 7. That's a system of equations. Again, it's a fancy name for solving two equations at once. We're just trying to find a solution for both of these. And as you can see, because they're x and y, the solution is going to have, an x and a y. So if you think about it, what I'm really saying here is here's two equations, and we need to find the solution or the point where they cross. So that's a nice thing about today's homework. If you can graph, which you can, because you've already taken a test on graphing, and we've done several homeworks on it. If you graph one equation, then you graph the other equation, and then you find where they cross. And that's really it. So that's the nice thing. This is called the intersection. Probably already knew that. That's called the intersection, the solution point, whatever you want to call it. So that's pretty much it. We're just going to graph some equations, find where they cross, and that's going to be our solution. There's a couple things we need to talk about before we just jump right into it, though. If you think about it, how can two lines cross? And we're talking straight lines, right? You might have something like this, where two lines just cross and they meet somewhere out in the middle of nowhere, right? You have a solution, one solution, and it is x comma y, right? Just like we just said. The other option, think about this. What if you graphed one line and then you graphed another line and they were parallel, right? We've talked about parallel lines before. Remember, the solution to this system is simply where the lines cross, where the intersection point is. In this case, they will never cross because they're parallel. So this one has no solution. Okay. Is there any other possibility? Well, there's one other one. What if we graphed a line and then you go to graph the next line and it ends up being right on top of the first line? Well, you could say they're the same line, but for semantics arguments, we're doing two different equations, so we're going to treat them as two lines. Remember, the solution is where they cross, where they intersect, where they touch. So really, aren't these touching everywhere? So what we would say here is this is infinite solutions. Oops. Infinite solutions or all real numbers. These are the two phrases they might use. Infinite solutions or all real numbers. So these are the three options. Be familiar with these because we're going to see all three today. You got one where there's one solution, they cross somewhere, and there's your point. You got one where there's no solution, and they never cross. And then you got one where the lines basically fall right on top of each other. You could say they're the same line, and has infinite solutions or all real numbers. Now, one other thing, and this is a little bit annoying because they don't do this in every problem. There is an official definition for these rather than saying one solution, no solution, infinite solutions. Sometimes you'll be allowed to say that. Occasionally, they're going to ask you for more specific phrases, and they go as follows. No solution is technically called and I'm writing smaller so I can fit it, inconsistent. Inconsistent is the official word here for no solution. When I use the big Sharpie, sometimes the letters blur, so I wanted to use a little bit finer point. No solution is inconsistent, meaning inconsistent means no solution. So that would mean these are consistent, both of them, because we do have solutions for these. So first thing to remember is inconsistent means no solution, consistent means solution. Now, how do we tell the difference between these two? Well, these are two independent lines going their own way, right? They crossed here, and then they kept going in different directions. So we say these are consistent and independent. We say these over here, they're consistent because they had a solution, but they're the same line, so they're dependent. Inconsistent is no solution, and then these two are consistent, but independent and dependent. So make sure you know those names. That'd be really annoying if on the exam you graphed the question right, but you weren't sure what the phrase was to call it. So, and they don't use this on every problem, but they do it in probably half of the problems. So just, make sure you know the vocabulary here. Take a minute, catch up, and we are going to just start graphing pretty much, guys, okay? All right, so like I said, this is pretty much a graphing homework. Just graph one line, graph the other line, see where they cross. We'll do two ones that aren't too bad first. We'll do a couple ugly ones. Oops, I got that upside down, don't I? We'll do a couple ugly ones. And that's really it. This is really just, if you're good with graphing, this is not going to be a big deal. If you're weak with graphing, good news, you're going to get a chance to practice here. All right, so let's go ahead and on this first one, do that system that I wrote out on the other page. Y equals 3x minus 5 and y equals x minus 7. Let's go ahead and just do those. They're both in y equals. This should be nice and easy, no big deal. First one starts at -5, -1, 2, 3, 4, 5, right there. The slope is 3. Hopefully by now you realize what that means. That means to go up 1, 2, 3 over 1. Now with the system of equations, I kind of like to keep going with the dots because I want a nice clean line. You guys are doing it on the computer, so it's a little easier for you. But if you're doing these by hand, I'm going to go again. 1, 2, 3 over 1, 1, 2, 3 over 1, because you don't want to like draw these lines skewed and then, you know, be a little bit off. So that would be that line. What if I go the other way? Wouldn't it be down 3 and left 1, right? Down 3 and left 1. So be careful when you're drawing these lines, all right? In fact, I'm going to use the finer point pen to do this. But now at least we know what points it falls on. It's still not very clean because I still don't draw very clean lines, but it's better than nothing, right? Now the other one, y equals x minus 7. This one starts at 1, 2, 3, 4, 5, 6, -7. And the slope is 1, positive 1. So it's going to go up 1 over 1, up 1 over 1, up 1 over 1. And we can, you know, do as many of these out as you need to get a nice clean line. Because remember, they're going to cross somewhere. And you may have just seen it. And you need it to be very clear about where they're crossing. So don't draw these sloppy. That's the thing. If you're doing this by hand and you're doing this on paper, you need to be very clear about your lines. It does not hurt to have many, many, many points. All right? Now, we look at these two lines. And they did cross, and they crossed right here. Now, again, this is not the highest definition video. So I'll go ahead and just tell you, they crossed at -1, -8. Try this one out on your own and make sure you see where they're crossing. Maybe use a graph from the computer to try to verify this. So unfortunately, because this is just a low resolution dot cam, you may not be able to see exactly where they're crossing, but they are crossing at -1, -8. And I know that because I did the dots out cleanly, and that's where both of their dots fell. So this does have a solution, -1, -8. Remember, that would be consistent. And because they're two different lines, independent. All right? So take a minute, make sure that's clear, and that's really all we're doing here. All right? I don't know why this is looking like weird like that. All right. So let's try the other one. What if they gave you something like this? X equals 3, y equals -4. Well, just like I told you before, you're not going to get away from the vertical horizontal lines, which hopefully by now you realize that's what this is. So x equals 3, that's a vertical line at 3. Luckily here, we don't have to do a ton of dots. We can just follow our vertical line at 3, and there's x equals 3. Y equals -4 is a horizontal line at -1, 2, 3, 4, so right here. And really, these are probably the easiest ones because where they cross should be very apparent. It's at 3, -4, right there. One solution at 3, -4. So these are both examples of, you know, situations where you had just one solution, which we said again is consistent and independent. So take a minute, make sure you understand the basic idea here. We're graphing one line, we're graphing another line, and we're finding where they cross, okay? We'll go ahead and do a couple uglier ones here in a minute, but that's really what we're doing in this homework. All right, let's try to adjust the lighting there. Maybe that's a little bit better, hopefully. So let's go ahead and keep going. Let's do some more. They're not all super easy. That's the thing, because as we've talked about before, graphing is not a one-trick pony. You can't just use mx plus b every single time. So I wanted to show you one where y equals mx plus b is not really going to work, and how would we get out of that situation. So in this case, our system of equations is maybe something like x plus 2y equals 0, and, you know, 2x minus 3y equals, I don't know, -14, something like that. So first things first, you recognize this is going to be a little bit more of a pain because they're not in y equals mx plus b. So go ahead, take a minute, get these into y equals mx plus b. We have x plus 2y equals 0. So I'd subtract x from both sides, right? And that would give me 2y equals -x. Divide by 2. and y equals negative x over 2. So that's what our first one turned into when we wrote it out as y equals mx plus b, y equals negative x over 2. The second one here, I guess I'll use the bigger Sharpie. That's not showing up super well, is it? The next one here, we had 2x minus 3y equals negative 14. I'm going to go ahead and subtract 2x from both sides. So we have negative 3y equals negative 2x minus 14. I want to go ahead and get y by itself, so I'm going to divide by negative 3. Watch your signs. So in the end, this one becomes y equals 2/3 x plus 14 over 3. And so you probably see the issue here. 14 over 3 is not a y-intercept we can easily graph. So we've got y equals negative x over 2 and y equals 2/3 x plus 14 over 3. If that 14 over 3 was a 7 or a 9, we'd be fine. We could just graph it like normal and we'd be good to go. The problem is it's not. But let's start with the first one, y equals negative x over 2. You should be aware, and you should recognize this, that this is the same as negative 1/2 x, negative 1/2 x, negative x over 2. So think about, where would that line start? Where would the graph for negative 1 over 2x start? Well, it would start at 0 because the y-intercept is 0. The slope is negative 1 over 2, so down 1 over 2. And again, because I am doing this by hand, I'm going to keep doing this. Down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. If I want to go the other way, I'll need to reverse it. Up 1, left 2, up 1, left 2, up 1, left 2. And again, I'm just doing this so that I have a nice clean line when I go to draw it, okay? In fact, I'm not even going to draw the line until I'm done, because if I can get 2 of these points to land on top of each other, well, that's where they're going to meet, isn't it? So that's the first line, y equals negative x over 2. Make sure you're cool with that. This one here, y equals 2/3 x plus 14 over 3. I know what 2/3 is. It's 2 over 3, up 2 over 3. But 14/3 is what? Like 4 and some change? This one's gonna fall. Its y-intercept is gonna be somewhere here between 4 and 5. And I don't know exactly where. And I don't want to ballpark. So this is where you got to remember there are other ways to graph than y equals mx plus b. What are they? Think about the other ways to graph. We talked about the x and y intercepts. Should we try that? Well, no, because the y-intercept is one of the problems. If you can't get the y-intercept from y equals mx plus b, then using the x and y-intercept method is going to give you the same y-intercept. So the only thing we have really left is a table method. If I can find, think about the dilemma here. I want you to understand what we're doing. We're trying to graph y equals 2/3 x plus 14 over 3. The problem is the starting point, right? I know the slope, 2 over 3. The problem is the starting point. So that starting point is just useless. What I'm going to have to do is use the table method, plug some other numbers in, and see if I can find another point that is clean that I can start from. You don't have to start from the y-intercept. It's what we do because it's easier, but you don't have to, okay? So what we're going to do, I'm going to go ahead and do this on another sheet of paper, simply because this is kind of messy and I don't want to cram it in here. So let's just do this right here, kind of do it underneath it. All right, so we've got y equals 2/3 x plus 14 over 3. And I want to, I need 1 point to start with because that 14 over 3 is sort of useless. All right, so remember how the table method works. You just pick a point. Let's pick 1, plug it in and see what happens. Y equals 2/3 times 1 plus 14 over 3. You will have to remember how fractions work here. So y equals 2/3 plus 14 over 3. Luckily, same common denominator there. That gives us 16 over 3, which is just junk. 1 gave us 16 over 3, which was just junk. Because again, we're trying to find a clean point. I already had 14 over 3. 16 over 3 doesn't help me any more than 14 over 3 did. So we can try -1. We could try what else? Let's try 2. Let's do that one over here. So we got y equals 2/3 times 2 plus 14 over 3. Remember how fractions work. You multiply straight across. That's 2 over 1. So that's going to be 4 over 3 plus 14 over 3, which is going to give us 18 over 3. Well, that's useless too, isn't it? No, it isn't though, because 18 over 3 is 6. So there we go. There's the point we needed. When x was 2, y came out to be 6. So I got 2 comma 6 as my starting point. And that's all I needed. Beautiful, that's it. So 2 comma 6, we go back to the other graph. And we say, look, I need to graph this. The slope is still 2/3, but now I'm going to start at 2, 6, because that's much better than that 14/3 jump. So I'm going to start at 2, 6, which is right here. And my slope is 2/3. So that's up 2, right 3. Do it again. Up 2, right 3. Remember, if you want to go the other way, you make it negative. So down 2, left 3, down 2, left 3. Uh-oh, I think we just found our intersection point, right? That guy right there. Down 2, left 3, down 2, left 3. Again, you're doing this on a computer, so this is going to be a lot less of a pain for you because you guys aren't going to have to sit here and do this like this. But in a paper pencil class, well, I don't know, that's not working either. In a paper pencil class or a normal class that wasn't online, you would have to do these by hand, so it's good practice to be able to. Just go ahead and fill in our lines here. And we know where they crossed because we were careful with our dots. They crossed at -1, 2, 3, 4, 2. 4, 2 is where they crossed. Make sure that makes sense to you guys. Okay. Now, the question is it inconsistent? Oops, excuse me. Is it -4, 2? Excuse me, almost messed up there, didn't I? Let's rewrite that. -4, 2, not 4, 2, -4, 2. -1, 2, 3, 4, and 2. So now the question is, again, do you remember the vocabulary? Because there was one point. This is independent and consistent. So they're not all like this. Most of them will be a lot easier than this. I just wanted to show y'all one where, you know, y equals mx plus b doesn't work. And we had to go and do the table method until I found a point that I could start with. Okay? So just keep that in mind. Not everything is going to graph with y equals mx plus b. That's sort of the, I don't say the point, but that's sort of the idea, is that you have multiple methods. Okay? Let's do a couple more of these, and then that's probably going to round us up. Actually, we can do one with 2 on there now. I think that was the only one that was real long and nasty. So let's go ahead and graph, let's do here, y equals 1/4 x plus 6. And then the other equation will be 4y equals x plus 24, something like that. Okay, here's your system. So again, first thing to do probably is get y equals mx plus b. The top one is already in y equals mx plus b, so we can go ahead and do that. This one starts at 6, 1, 2, 3, 4, 5, 6. Slope is 1/4, so that's up 1, right 4, up 1, right 1, 2, 3, 4. Can't go all the way there. And then, so again, if you want to go the other way, just make it negative. Down 1, left 1, 2, 3, 4. Down 1, left 1, 2, 3, 4. And then we're going to run out of room. So there's that line there. Now 4y equals x plus 24. We're going to have to get that into y equals mx plus b. Luckily, not a big deal here. We're going to divide by 4, divide by 4, divide by 4. So that gives us y equals x/4 plus 6. So this one starts at 6. So you already know where they're going to cross because they're starting at the same point. X/4 though, what's that slope mean? Well, isn't that the same as 1/4, right? 1/4 and x/4 mean the same thing. So this line's going to go up 1/4, up 1/4. So what we have here is the same line. Both lines, and you might have seen it from here. As soon as you got this, you might have said, well, hey, hold on, these are the same. And they are. So this is an example where the lines overlapped each other, or like I said, you can say it's the same line. So this has infinite solutions because they're touching everywhere. They're touching here, they're touching here, 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 everywhere. Infinite solutions, which officially is consistent and dependent because they are the same line. Okay, so watch out for that. Can happen. Let's do one more here, and I think you guys will have the idea. Again, you're always welcome to email me if you have any questions, as usual. So here we have 2x minus 5y equals 20. Then we have 5y minus 2x equals 15. So neither of these are in y equals mx plus b, so let's go ahead and do that. Let's do that on another sheet of paper right quick over here. You know, just for room, because I don't want to have to squeeze it in there. So we have 2x minus 5y equals 20. We need to get this into y equals mx plus b. So I'm gonna go ahead and subtract 2x from both sides. Remember, we're trying to make y equals mx plus b. So put the mx first, mx plus b. You could put the minus 2x behind the 20, but I mean, why? It just makes it look ugly. And now divide by -5 everywhere. Some of y'all were making some sign mistakes on the test. So y equals 2 over 5x, and 20 over 5, that's -4. So our first equation is y equals 2/5 x minus 4. That's what that first guy turned into up there. Y equals 2/5 x minus 4. The other one was 5y minus 2x equals 15. Same kind of idea here. I'm going to add 2x to both sides. So we got 5y equals 2x plus 15. I'm going to divide by 5 all things, all pieces, all sides. So we got y equals 2/5 x plus 3. And that's what that one turned into. So really, guys, I mean, you're still going to have to graph them because it's a two-part situation. They're still going to make you graph them. But you should realize the answer already. What kind of lines are these? 2/5 x minus 4. 2/5 x plus 3. They have the same slope. They're parallel lines, aren't they? Because they don't have the same y-intercept, all right? So we already know parallel lines are only going to meet, well, they're not going to meet ever, are they? So we already know the system is inconsistent. We still have to graph it, though, so let's go ahead and do that. So let's start with the first one, 2/5 x minus 4. That starts at -1, 2, 3, 4. The slope is 2/5. Up 2, right, 1, 2, 3, 4, 5. Up 2, right, 1, 2, 3, 4, 5. And again, if you want to go down, make it negative. -2, 1, 2, 3, 4, 5. Down 2, left, 1, 2, 3, 4, 5. So there's our first line. Oops, kind of missed it, but you guys get the idea. Second one is at +3. And it's the same slope. So it's going to go up 2, 1, 2, 3, 4, 5. Up 2, 1, 2, 3, 4, 5. Down 2, 1, 2, 3, 4, 5. Down 2, 1, 2, 3, 4, 5. And if you draw it right, which I didn't, but you still get the idea, you'll see that they're parallel lines and they're not going to cross anywhere. So this system is inconsistent. That making some sense? Hopefully so. So we saw a couple examples early where there was one solution, one that was a little more difficult than the others, where we had to use the table method. Now we've shown you one where they're the same line, which is consistent, or infinite solutions, consistent independent. And here we've seen one where they don't have any cross at all. They're parallel lines, so they have no solution or inconsistent. Okay? And that's really it for this homework, guys. So if you can graph, this shouldn't be too big a deal for you. Just watch out for the ones that have the tricky y-intercepts. You may have to use the table method here and there. And as always, I'll see you guys in the next one.